Good morning. Thanks so much for joining me here in my shop. Today is February 9th, and it's still cold outside, but not so cold like it was. About -5 here today. I think it's going to go up to around freezing, and we might even get rain. Oh my gosh. But another cold spell is coming in a few days. Hello? Hello? I didn't get anywhere here today. Oh my gosh. Peanut? What? Well, that was quick. Okay. He just wanted to make himself known there. Yes, that's my cat saying hello. Okay, now, the last video, the first video on this, ended with me testing the two vacuum tubes and finding them both to be weak. So I have a couple of good replacements here we're going to put in, and we're going to try the oscillator again and see if by some chance the audio oscillator is working also. I'm just going to pop these in here. So I think the fact that both the tubes were worn out is an indication that this unit was on for extended periods. And I think another hint on that is the light that was installed down here. Somebody went out of their way to put that light there so they know the unit was on. So you can imagine, it happens to me here too. Sorry, end of a session I turn the lights off and then I see little indicating lights still on some of the equipment. Oh, I got to turn that stuff off and not leave it on. I think this guy got left on a lot. And that's why the 1287s are both worn out. Now, are we all set here? Is it that simple? Just start doing our testing? Yes, it is that simple. Okay. Apply some power. Still do it through the dim bulb. This wasn't quite off. Here he comes again. He's coming around for another one. We'll put this on the 15-volt scale. What, have you changed your mind? Peanut? You want to go out? You can't go out. You still got to wait another month or two. Yeah, I know, it's sad. It's a sad... I know, it's a sad thing. Yeah. Okay, I know what he wants. He wants to go and spend some lap time with me. So in fact, that's what I'm going to do. Yeah. Okay, I've got to abandon the show here for now. Too bad. That's a rough start. Right? Peanut? Okay, that was kind of quick. Turns out, ow means food. Ow means all kinds of things to that cat. Okay, we're good to go here. So we're going to want to listen to the oscillator. It didn't seem to be particularly strong. Don't imagine it to be very strong. Let's try it again. This is 600. This, whoops, the radio's dialed up to 600. We'll put a lead into the RF out. Let's get this out of the way here. And we'll turn it on. Bingo. That's much stronger, I think. Yes, that. Now the difficulty with doing this is there's no real clear spot on this radio to so let's turn this off. Oscillator off. Can he find a quiet place? Right down here. 575. Where'd it go? It was there, and then it left. Okay, there we are. It's definitely the output from on this wire. Modulation on and off. Something disappeared. Back on. So it sounds like a 2000 cycle tone, but it's heavily interfered with. Let's go up on band B. We'll dial up, let's say 900. Be around 900 there. 900. Not so good here. Gotta clean these switches. I mentioned that before, but I haven't done it. Make that high on the list. There we are. Modulation. Well, it's definitely there, but it's not a nice clean tone, is it? Okay, so that's the RF part of it. Let's see what we can find out about the audio output now. I'll use the voice coil. Another speaker again. Audio level down. Again, to use this technique, we've got to make two connections into the analyst here, the VTVM negative and the voice coil. Oh, I hear something already. Well, this doesn't seem to do much. Seems distorted and weaker than I would expect. I would expect this test to produce a much stronger sound. I just would think they would make the machine that way. What else could be set wrong here? Maybe any of this stuff up here. Audio level doesn't do anything. Made a small change in the tone, but it doesn't really matter. It's just turning the RF on and off. Okay, I think that's it for that. This other audio output is a low-level signal meant to be fed into the base of the audio transistors in a radio that's connected to this power panel here. Otherwise, you can't do much with this. That's the name of the game. Okay, so the tubes are involved in two things. One is the oscillators, and the other is the VTVM. So let's test the VTVM at this point. We'll see what we get out of it. Okay, I'm almost set here. Just put this into the positive. We're on the 15 volt scale. And me another pin here. I'm going to have to make up some test leads that are going to work here. These are all bad. These are all loose. Not sure what I'm going to do about that. So this is onto the voltmeter. Onto the VTVM and the power supply feeding it. Okay, 15 volts. I think you just set this to 15 volts. That's a 15 volt meter on these terminals. I think that's all there is to it. Okay, output is nothing. Here we go. What do you say, meters? I'm watching this meter here. Hello meter, hello meter. Okay, so it's 10 volts, it's showing nothing. It's not working. Maybe it's just bad contacts here. Get a little bit up. It's about 8 volts here. Am I really doing this right? Do I need to double check the end of this? I should. I should. On account of stuff happens. Okay, that's on the 20 volt scale. There, I'll do it like this. There it is, 7 volts. So the voltage is getting right to those terminals, but not onto the meter. The meter with the stubby pointer. Other scale. So turn this right down again. 1.5 volt scale. I thought I saw this thing work. Didn't I see that? Didn't I see that before? Here we go. No, you know what I saw? It's going up a little bit. So it's sort of reacting, but not at all properly. And that's going all the way up to 15 volts there. So something wrong there. Now, we did try the transformer test, the tubes. They're probably involved in that in some way. The VTVM tube is probably involved in that. But it seemed to read correctly. It seemed to do the trick. So I'd have to study the schematic to really know. But it strikes me the only way you can get to this meter movement is through the tube. So what is that telling me? Now if we flip over here to the current ranges, so the meter shot backwards there for a moment. This is upscale. Like if I go here, I'm lying. I'm completely lying. This just went down. The question is that the relaxed spot? Or is that relaxed? Let's find out by cutting the power. Cut the power. Okay, power's gone. Meter's staying up. Let's go here. Well, isn't that interesting? I think that's interesting. So the meter's relaxed point is up here. It's not resting on zero. It may have to do just with this adjustment I fiddled with yesterday a little bit. Let's fiddle with it some more. So I can see the movement inside the meter movement itself, and it's not adjusting back and forth as I turn the screw. It's very common for these screws to be disengaged from the movement when somebody takes the cover off. We gotta get the cover off. Gotta get the cover off this meter. Now, there are 4 holding screws. And let me just pull this out here, just to be doubly sure I'm not going to get a shock. So we have 4 nuts here on probably what are permanent screw posts coming out of the back of the meter. You can actually look down here and see them from behind the backing plate. So most of the time these plastic covers are just snapped in place, and it's always a little bit scary to get them off. So I'm seeing what looks like a snapping grip up here. You see something funny going on the sides. And what about down under? So down under looks a little Why don't we take a closer look at the situation here before I end up breaking something. Okay, we'll go around it one time now. I think I see what looks like a gripping point Let me just get some point width here. Right in here. That's typically how it's done. A little plastic tab or bump. What's this over here? Is this another one? No. Okay, I'm going to go up the side here. See if someone could glue this back on. And that's what that looks like. That looks like a dab of glue. Looks like another gripping point here with a dab of glue. No, please don't have glued this. Nobody glue these things. Sometimes these tabs get damaged in that, and then it won't retain. That looks like a dab of glue. Oh boy. And what's up on the top here? Looks like an unglued tab. This also looks lifted right up in the corner here. Looks already lifted a bit. Okay, that's a pry point. That's helpful. Let's give this a go. We'll see what happens. This is coming right off. Pause. You can see the plastic cover's coming off and the meter movement is staying behind. No problem here. There we go. No problem. There's retention bumps in all corners, and it looks like these did get dabbed with a bit of glue, but didn't stop me. Okay, now we're going to switch and take a close look at the movement. Okay. Let's do that. We'll take a close look. And we'll start with this camera. This particular camera doesn't go as close as I have another camera that can get even closer. Look at it. So here's the adjusting part, and you can see there's a pin right on the top of it here. And that pin has to find its way between the forks here, and it can move this piece. I'm going to get the other camera because it's just a little closer. I want to really get in and close look at this guy here. Okay, it's going to take me a moment. That's just a fraction of a moment in video time. Okay, we'll switch to the other camera here. Go in for a good close look. Let me just get some lighting ready. So first I'm just looking for anything that's unusual. Look at that pointer. Now, that looks like a big whack of glue. This looks like a really clumsy. So, I'm not the first guy to glue a new pointer onto here. Now, whatever happened to the pointer? It wasn't inside here. So you would think if it fell off, it would be laying inside. Well, that's a bit of a mystery. So we look right inside the movement here. I need even more light. Now, these things are very highly balanced. The pointer is counterbalanced. You can see, let me move the pointer a little bit. The swinging arm has a bunch of copper wrapped around it in the lower right area there. Let me point to it just to make sure. It's kind of obvious right here. This wire is the counterbalance weight. Compensate for the pointer up above. I'm going to glue on there. Glue all over the front. Why all the filthy fingerprints? Like, what was going on here? It's like a crime scene. It's a crime scene. Very tricky to light it. So I don't think there's anything really wrong with the movement at all. Let me pull a pointer up. Seems just fine. Let's see if we can zero it better. Well, it's actually sitting at 0 now. How come it's at 0 now? I'll move the adjustment here. Try to move it. There it goes. Move the other way. So basically what's going on here is there's a spring, a circular, very light circular spring in there. There it is. You can see it now. And the end of that spring is fixed to this. So as you turn this around, you change where the spring is terminating. Of course, the other end of the spring is on the pointer, and that's what the magnetic field is pulling the pointer against this spring. This very light spring down here. And correct me if I'm wrong, sometimes, yeah, I'm probably wrong. There's current on the spring, but I don't know about that. You'd have a coil inside the movement that is going to rotate when you put current through it, and then but how are you going to feed current to it when it's going to rotate? So one way would be one terminal is the what do you call it? The pivot, where the shaft goes into a pivot point under here, and then the other supply is arranged through the spring, which we were looking at a moment ago, but can't see now. So I think, one risk is you burn the spring, burn the connections. There's the spring there. I think. I'm not really sure about that. So let me do a little more movement of this thing. I'm going to move it with my finger. And just watch what happens here. So see it go up and go down. So I think all that was wrong is that plastic thing was not engaged. So to get it engaged, we'll set this straight down. Like so. I'm probably going to leave the cover off, in fact, or I don't want to snap it back in. Snap it back out. But you would leave it down like that. And then you'd be wise to switch cameras. And all you got to do is just set this so the pin is down. And put it together very carefully. And it should go right into place. So it's pretty important to, I just showed this to a camera that wasn't over there. Yeah, it's over here. Yeah, so I think you knew what I was doing. You're just setting the pin to the bottom here, so it'll line up with the forks. If you don't do this, there's a chance you're going to collide with the forks, bend them, or you can get the pin on the outside of the fork, and you'll be able to move it one time. The fork will travel, and then that's it. It'll be stuck wherever it's stuck. You'll never be able to zero the meter. It's not scratched up. Okay, kind of lost track. What was I doing that for? I was doing that to try to check this zero situation, which didn't seem right. Now, when you lay a meter down or stand it up, it can make a difference, particularly if it's not balanced. And of course, this meter is not balanced without the pointer. And is it ever going to be balanced? We're going to end up putting something on there as a pointer, up piece of wire or something like that, glue it on there, but it will never be balanced properly against the counterweight in a precise way. And what that means is when you stand this unit up or lay it flat, the forces on the pointer, the rest forces, will be different. So you stand it up and it may drift upscale. The zero may go upscale. Lay it down and it may go the other way. So is it a big deal? I don't think so. I think I can probably get away with doing stuff here. What's the next step? What is the next step? The next step is to figure out why the VTVM isn't VTVMing. Yeah, I think I'm going to focus on that next. Maybe I'll try cleaning up that meter face because those fingerprints are driving me nuts. Okay, a little tricky to get this on camera. So the first thing I tried was just some detergent, just a Palmolive, in fact, just dish detergent. Didn't really do anything. Now the camera's not doing this justice at all. This is not showing. It doesn't look like that in reality. You see some white stuff on my fingers here. So then I just grabbed some alcohol, put a little on my paper towel, went over here where I didn't think I could do any damage, started wiping, and sure enough, the oil just came right up. Also, the white paint here came right up, right away. It just dissolved it instantly. So I think I've lightened some of the paint up just in here. So I'm not so bad where there's no words. Oh, look who's here to help me. Oh, the help I need, yeah. You're the help I need. So if I do this very carefully, yeah, it's just taking the paint right off. You know, what else would I try to use? Kind of loosens up the white paint, and then the white paint drifts on top of the words and covers them. I'm sure maybe it's just the white paint. I need a touch more. I need something better than a piece of cloth here. Uh-oh. Goodness knows where I got a cotton swab would be the perfect thing. Okay, I gotta hunt down a cotton swab here. Somewhere we've got some in our house. Okay, so I did manage to find one. I've cleaned this as much as I dare. Very interesting. The alcohol dissolves the white paint. You can see it on my finger almost instantly. But then the white paint on here just starts moving around. It just turns into a paintbrush. Doesn't seem to dissolve the rest of the print, but I certainly haven't tried it. I've never done something that had this kind of effect. The result is that you can really clean the white stuff because it takes off the top layer. It's like that paint you can buy for outside your house. They call it chalking paint, and I assume you can still buy it. And you paint your house with it, and it stays white for a long time because the front surface of the paint is degrading and turning into a chalk powder, and then it's washing off in the rain or coming off in the wind or whatever, and keeps revealing a new surface. So your paint is sort of self-cleaning for some period of time, and then it's gone. It's kind of the same with this. Okay, that's enough of that. Okay, now what were we going to do? We're going to go after the VTVM. Okay, on my own, I'm going to study the schematic until I understand it properly, and then we'll try and make the VTVM work. It's critical to make it work. Okay, I think the next smart thing to do would be to check these tube voltages, excuse me. So they're listed on the sheet here. So one tube has 100 volts and 100 volts on the plate, plus 3 on the cathode, and the other tube has I thought I saw it here. It looks like 15 volts on this plate and 108 volts over here. There's a lot of precision resistors, 1% resistors in it around here too. So why don't we go looking for it now? Which tube is which? So it's not obvious. What I did was I looked at the pin arrangement under here, and I noticed on this tube, yeah, the other tube's back here. But this tube, pins 3 and 8 are shorted together. So when I look here, it turns out 8 is here, 3 is here, and they're not connected. And on this tube, 3 and 8 are tied directly together. So this tube is this tube, which is the bridge tube. That's the bridge, that's the oscillator there. Okay, so we know which is which. So we know which pins are what. And we know it's all a reference to ground. Now what is ground on here? Is ground this metal plate here? What is ground? That's a good question. So off of pin 3 and 8 on that tube is a resistor, 560 ohms. It's a cathode resistor, and at the other end of that is the ground connection. So can I find all those goodies in here? Let's see if I can. So that would be, let me get a pointer. Hand me a pointer. So let's see. So here's 3 and 8 tied together. Would look like this is a big lump of solder here. Oh boy. And it looks like the resistor jumps from here to here. Let me just take a look here. See if that's really the case. And alive. That is what it would look like. So that would make this the ground. It happens to be right on the outside of the board. So I'm going to follow that around with my eye. Around and around and around it goes, all the way around the outside, and hooks up to a big area here. There's a screw in it, a hold down screw. I think this has got to be the ground. This has got to be correct. So the ground, at least here on the board, is represented by this trace up here. That's what I think is going on. Now, surely to goodness that ties to some ground over here. Might as well resolve it. So I see really no connections to this metal plate anywhere on here. Not even a single connection. Maybe if I look long enough I'll find one connection, or it's hidden somewhere. It's likely to be a rivet, like this is riveted to it. There's rivets all through here. This is riveted to it. So on the schematic there was no indication that this metal plate is tied to the what would we call it? B minus? Ground? I don't see anything here. So that's going to remain a bit of a question, just what's going on. The two screws back here are actually the frame of the capacitor. And there's this bracket that comes down here, and it's connected, it's riveted and soldered right here. So this would be part of the ground also. Kind of running around the outside again. Okay, not completely helping. The reason I need to know the ground is I need to know where to put my negative probe. Now this looks like a good spot right here. So this is called VTVM negative right here, and there's lots of black wires connected to this spot. So I'm willing to bet this is a ground point. One wire comes to this terminal. This terminal's got a lot of stuff on it, including the negatives of the two capacitors I put in. Wait a minute, that's the positives. What? So these two capacitors are just in parallel. And I've tied the negative back here. Did I do that right? I'm sure I did that right. I'm sure I did that right. Oh boy. Okay, so we look at the negative here. Do we find a 20 with the positive hooked up to it? Oh my gosh. Self-doubt, you know. It's good stuff. Self-doubt. Good stuff. So what did I say? We look at the negative terminal. The negative terminal of the VTVM. This guy is right here, and they just show it dropping to the ground connection. Well, that ought to do it for me, shouldn't it? I mean, it's written right there. So if we now look at the 20 capacitor, where is it? That's the 10. Here's the 20. And we see positive, we see negative tied to the ground. What have I done here? Oh my gosh. Did I get that in backwards? I'm really, really good at putting these capacitors in backwards. Oh my gosh. How could I have done that? I was so careful. It doesn't mean much to me. So the positive side goes up and connects to the center tab on this output transformer. So the positive side of the capacitor here is connecting to the, what I guess is the center tab up here. I've got the negative there. Son of a gun, did I put these in backwards? Come on, really? Really? So I hope this is something that my viewers like you appreciate, is that I don't hide my mistakes here. In fact, half the time when I'm working at my shop, I'm sorting out my mistakes. Well, it's clearly the negative lead. This is clearly a center tap because there's a lead here, and one in the center. There's a resistor coming off it, going out here. Resistor off the center tap, going somewhere. Oh my gosh, what a dummy I am. Where we were over here. Center, so there's the resistor coming off the center tap, coming off the positive terminal. There's the resistor and the center tap going to the negative terminal. Oh my gosh, what a bozo. That's me. Jimbo the bozo. It's got to be backwards and negative to ground. Okay, I managed to do it again. It's another fine mess I've got myself into. I'm going to rotate that capacitor around. That might help a few things. Okay, like I still, even though, you know, perhaps having these in backwards was disabling the machine, disabling the VTVM, perhaps, I'm going to still continue with the testing of the plate voltages. So this is the VTVM tube. Plate voltages are on pins 1 and 6. Got my voltmeter ready. This guy here, 150 volt scale, so 100 is up in this area here. That's what we're looking for. Was it not? 100 on each one. 100. Measured to the negative. There's my negative meter connection. We're ready to go. Okay, now I did do something here. Let's put the dim bulbs in. Yeehaw. No problem. Probably, maybe one of the reasons these capacitors hung in when they're, you know, electrolytic capacitors in reverse, not a good idea, is because these are 400 volt capacitors, so they probably withstood what little reverse voltage I subjected them to there. Okay, I'll give this guy the full Monty again. Today that's 117.3 volts. Okay, and we want to go on this tube 1 and 6. So 1 is here. And I'll look at that meter. Wow, that's low. That's all of 30 volts. Okay, and 6. 1, 2, 3, 4, 5, 6. 30 volts. 30 volts. And that's the one with the short between the pins. It's definitely the right tube. Ain't no 100 volts there. I do have this switched to VTVM on the front panel. So there's a problem. Now there are some calibration here, but you can't imagine it's going to calibrate it up. And you know, the calibration is affecting the, I think, one plate voltage. So both plates are low. Something in common with them? What is the output of the power supply? Up here. Where do you get 100 volts? Where do you get 100 volts? The output here is 17 and 17 AC. Where do you get 100 volts from? Unless they're taking the 100 and what's coming in on the line and doing something with it, maybe down here with these two diodes. There's big capacitors here. The 10A, the 10. Oh, where'd this one go? Because here's the 10 I did on the board. Here's the 20 I put in backwards. There's another one here. There's another one in there somewhere. Somewhere I haven't spotted yet. Well, I'm a little surprised at that, but we won't sweat over it right now. Carry on. So this has got to be getting its voltage from somewhere on here. Just track one plate upwards. Goes through a 5.8K resistor. Here's zero adjust. Go down here. Oh my gosh, look where we're heading, right to these. So they're deriving the high voltage right off the power line. Oh my, my, my. This is a non-polarized plug. It could be why there's no connections to this panel anywhere. That I found anyway. Because it's unsafe. Wow, I can't believe it, they would do that. Now I'm saying it's an unpolarized plug because somebody's replaced it with this old gunky one. This can't be the original. I just can't imagine that's the original. But this is old enough that it would typically not have a polarized plug because the polarized plug system didn't come in until sometime in the 70s, I think, here. Here, anyway. I don't know. I guess probably the United States going the same way in terms of using the polarized plug. Okay, so this opens up a new issue here. What's going on with this capacitor? This is a, looks like 1 microfarad. A small one. That's probably why I've missed it. I'm looking for big ones, and it's a small one, and it's not on the circuit board. So where are these diodes? So there's one right now. This should be easy to spot. There's one right here, and the other one is up on the board. Okay, so there's one on the board. Oh my gosh! So this one's on the board. This one's not. Well, there's still 1, 2, 3, 4 more. Are there 4 more? These are selenium rectifiers here. There's one there. It has 2 terminals, but it's bolted down to the chassis. This one looks exactly the same up here on the board. You can see it there. The green guy. Appear to be in good shape. These are not reliable devices. They wear or degrade, I guess is a better term, and part of the result of that is a higher and higher voltage drop in them. That's my understanding of it. Eventually they start running hot, and eventually they burn, they smoke, and apparently it's quite a disaster. I've never had such a thing happen. Well, that's 2. Now there's supposed to be a diode protecting this meter. I haven't spotted that. Is that it? Is that it there? That little blue guy there? Hooked up to this brown, black, black. That's a 1 ohm resistor? A 1 ohm resistor. silver banded 1 ohm resistor. Well, does that come into here somewhere? That's 123.5, 1%. Wow, there's 1% resistors all over the place in here. So we're looking for a diode with a 1 ohm resistor related to it. 82K, 15K, almost anywhere. That's a pot. Good. Capacitor, 560 ohms, 62K, a 1 ohm resistor. This guy's coming across here. Oh, goes in the switch, but no 1 ohm resistor. So what am I doing here? So it's coming off this switch. What is that switch? That switch is the PNP NPN switch. Let's tip this up and we can do it safely. It's a leakage and beta switch. That's what it is. Leakage and beta switch. They just call it switch 4. Switch 4 is the RF switch. Okay, I'm losing my mind here. Switch 4. Show me another. Here, switch 3. Switch 3. Leakage and beta test switch. Way over here. Way over here from here. That looks like it says 16 ohms there. I don't know. Okay, so I'm swimming around here. What we want to determine is there really that much voltage there to operate? So if we assume that it's off the 10, yeah, the 10 off, yeah, 10 through here, off the 10 capacitor, we should see 120 volts right there, right next to the diode, which is that one up there. So look at the capacitor I put in on the positive side of the capacitor I put in. Did I do that right? Okay, so this would be the positive side of the capacitor I put in. Oh, 30. So we got a supply of only 30 here. It should be 120. I think it's implicating these guys. I think that's what this is doing. Could look on the other side. I'm not sure what we would see there. Oh, wait a minute. There's a switch here. Switch number 4. RF on off. Why? Could it be when you switch on the RF, you switch off the vacuum tube? Let's operate that switch. See what happens. Okay, so we're up at the top. Come down one setting, and then we'll read the capacitor again. Same 30 volts. Same 30 volts. Okay, go another switch setting. Dirty switch problem. They haven't cleaned them yet. Gotta clean them. Off the positive. Every time I look over, I slide off here. 30. Is that really 30? 150 volt scale. 30 for sure. 30, 35. Well, these guys would be getting warm. I don't want to stick my finger on it. It's not this one. It's this one up here. Is it getting warm? You can tell by how loud I scream. No, there's no heat in it at all. Well, a little wee tiny bit of heat. Nothing to get panicky about, but that's not a guarantee that it isn't dropping a pile of volts. So the general practice for a lot of people doing restorations is to get rid of these selenium rectifiers, get them out, and replace them with just a 1 in 1,000 something. Problem with that is it jacks the output voltage of whatever it is you're dealing with, power supply anyway, up a little bit. Probably not a really big deal. So is there a way to test those in the circuit? Can get a voltage drop across them? But I'd have some trouble interpreting that. Sounds like I got to change these. Now the one up here on the board's fairly easy because both of its leads come down underneath here. Just get them soldered and pull it out. This one's more tricky because it is a terminal spot. You can see it's got a capacitor, a resistor, a couple of wires hooked up. So I'd have to probably put in some kind of terminal strip, but where are you going to do that? Oh, son of a gun. That's bolted in. That's excellent. So if I unscrew that, unbolt it, it's bolted to one of the terminals on the meter face. Probably just done for handiness. Can't imagine that's the ground connection to the metal plate here. I don't think there is such a connection. Not that I know of. Well, oh, I just found it. There it is. I have found it for sure. So here, what have I found? I found the connection to the plate, this metal plate. Pointer time. Okay, get another pointer. Let's try this one. So this terminal strip is also attached under a screw here, under a nut. And this terminal, yep, definitely comes right up. And this point is tied to this plate. The blue wire goes somewhere. The yellow go over into the switch here, doggone it. The brown wire goes to a resistor. Ground points attract a lot of things to be connected there. Not necessarily associated with each other. They're just using this as a ground point. So it can be a little confusing. Looking at that, I'm also noticing that this 1 ohm resistor, I guess this is the way they did it. It's got an airborne solder connection, which is not normal in manufacturing. So is it possible this might be an insert of some sort? This doesn't look vintage enough. Okay, not sure what I'm looking at anymore. Okay, next game. Turn off the power. Turn off the power before I get myself into trouble. Check the plate voltage on that other tube. Well, let's do one at a time. So it would seem to me perhaps these are two different supplies here. One for the plates of the VTVM tube, and the other one with the not yet found capacitor here. You know what? This capacitor does not have plus or minus on it. It just says 1 microfarad. Well, that's a 1. And I think this is probably a 1. And this is a 0.1. It's gonna, so this one is hooked right up to one of the terminals here. So there we are. That's it. So this guy is the filter for this power supply. And this doesn't look to be in the greatest of shape. It looks like I'm on my way to replacing these two. Wow, okay, so that's a fair bit of work. But this appears to be related to the other tube. Let's see if that's true. So off we come up here, capacitor. Whoops, okay, so off we come up here, over here, go into this 0 adjust, we come out. Oh, it's back to this one. Okay, so where's this guy getting its plate voltage from? It's plate voltage 100, and 15 on this side. So 100, where's he getting it from? Audio oscillator. Oh man. Ooh. Getting it from here. It's getting it from here. So, okay, gotta stop and think for a little bit. I should go ahead and change this. Change the one over here. And change these capacitors at this point too. Yeah. Well, I think that sounds like a good idea. Okay, so I have the first one out off the board. It's sitting over there. Let's look through that camera and take a close look at this. Well, it doesn't look to be in terribly good shape. It looks like something is happening to it. So is this the degradation of failure? It could well be. And that one piece there is bent quite a ways over. A little bit surprising to me. Oh, it's just powder. I think that's what a failure must look like in one of these guys. Okay, so I've picked a 1N 4003 to do this. That's got a 200 volt tolerance to it. I think that should be enough. Just have to make sure I get the polarity right. Oh my god, polarity on a diode. Okay, so I've replaced the diode here, replaced the capacitor there, replaced the capacitor here, and installed a diode here. You see the old green one is still there, but if you look, you'll see I've cut one terminal off. So I'm able to maintain the other terminal as a connection point and save myself a lot of work and problems. And I think that's going to be just fine. Leaving it like that. Good. So I think we're ready to test it again. Really? Is that really where we're at? Yes, we're testing the supply voltages to the vacuum tubes. That's really what we're up to. This is still connected. Okay, put 2 diodes in. Pretty sure I did it the right way. That doesn't mean anything, apparently. So we're going to get those light bulbs in view. As soon as I hit the power, power will come here. Okay, so we're watching the light. What are you doing? Oop, that didn't look good. That didn't look good. Yeah, what happened there? So I saw the light come on and go down, and then it come on again and go down. Do you hear that? I think I hear an oscillator screaming away in there. Okay, voltage measurements. Voltage measurements. Let's do what we're going to do. Do what we're going to do here. Okay, it was pins 6 and 1. 6 and 1. This is 1. Look at that. 90 volts this time. And 6, 9, 8, 7, 6. 90 volts. And that's with a reduced supply. Let's give it the full works now. Oop, it's even going louder. She's gonna blow. She's gonna blow. 110 volts. So that's probably a little extra because of the change in the diode. Okay, power off. Fantastic. Nothing blew up. Everything seems okay. Did not see any smoke. Well, we should check the plate voltages on the other two. That's what we should do here. So the other voltages should be 15 volts and 108, which is going to translate to like 16 or 17 volts and 115 or something of that sort. 1 and 6. 1 is the lower voltage guy. Power back on. Okay. Where's the oscillation? Here it comes. Okay, our voltage 117. Now, 1 was the 15 volts. So 15 volts over here, I'll put this on the 50 volt scale. 15 volts is about here. 15 volts on 1. So it's about 17 or 18. And then 6 was going to be 108, which I figure is probably closer to 120. 9, 8, 7, 6. And we're reading 128. So it's quite a bit higher. Is that going to cause a problem? 108 to 128? Not enough for me to worry about. Okay, power off. We'll check some functions now. Okay, I gotta get this ready for that. Coming along. Let's do this. So that's one of the capacitors I took out, which looks really sealed up. Let's see if it was worth changing. Okay, so it shows about 900 nanofarads. That's just short of 1 microfarad. V-loss, nothing. ESR, almost nothing. So that's a good capacitor I didn't need to replace, but I did. Okay, I think it's time to test this guy out. Let's just set the 0 here a little better. Okay, seems okay. Ready to put voltage into the voltmeter input. Unit set to 15. Here we go. Something's humming. It's got a pretty good hum in it. There goes the oscillator. Let's see what happens if we turn it off. Ha! Okay, oscillator off for now. Voltmeter. This appears to have, it's being pulled downwards. That's probably because of an adjustment being out of whack inside. Definitely being pulled downwards though. So I can compensate. It's not the right way to do it, but let's just, I can't, yeah. Okay, this is not the right way to do it. Is it jumping around a little bit there? Okay, what do we get when I turn up the supply voltage here? Yeah, I've also cleaned the switches and the controls here, or at least I put some spray on them, just in case. Okay, up we go. 15 volt scale. Look at that. Look at that. Okay, so I'm on 10 volts. This is on the 15 volt scale. 10 volts would be here. But I'll bet you there's some adjustments that can be made to correct this. In fact, I've read in the manual how to do some, let's call them alignment adjustments. We'll try the 1.5 volt scale. Okay. Now, a little tricky to put just 1.5 volts out. So on my meter up here, that's 2.5 volts, and it's upscale again. Probably just a meter adjustment in the back. Fantastic. Okay, what about ohms? Okay, so we'll pull this out of here. And we'll flip this to ohms. Oh, it went up. Just see if it's sticking at that point. No. There's a ohms adjust here. Look at that. infinity. Now if we want to give it a 0, we'll give it a 0 here. Assume we just use it right down to 0. Fantastic. We're doing great. Oscillator test. Okay. So if this radio is tuned to 900, we'll shoot for 900 here. Put this in the RF. Switch this to band B. Stay in there. Stay there. Okay. So 900 would be about here. Much stronger. Much stronger than when we started. Let's put on the modulation. Tune it in. Modulation. Now that sounds like 2000 to me, that high pitch. Modulation level. Doesn't seem to do anything here. Is this really modulation level? Audio and RF level, not modulation level. So this should be killing the RF a little bit. Oh, this thing's really issuing it right out of itself. Not sure there's any level change there. You can see the power meter, or the level meter on the radio here. Let's get it weak. There. More, less. Well, it doesn't seem to be any more or less. It's the same, but it's working. Let's just double check band A. Band A, we'll turn this back on. Dial this down to, let's say, 750 kilohertz. And that would be right around here. Probably another signal it's picking up. Not a lot in the way of, hey, this thing's still moving. Oh, I still have this on ohms. Yeah, okay. Now, this thing makes a squeal itself. That's a little unfortunate. I really don't want to hear anything coming right out of it, but we are. So there are some tests that can be done in circuit, and when you do them, you're supposed to monitor the current being drawn by the radio. So you would set this to 15 millimeter, just shooting downwards there. Now, is this because I got this moved way up here? Probably is. Yeah. So we'll get this down to 0. Here's the challenge. This light is drawing some amount of power. You know, little transistor radios don't draw much power. I mean, they draw more than this, but this must be enough to show up on the meter. 15 milliamps full scale. What's this take? I don't even know. LEDs take what, a milliamp or two? This should really probably be up here somewhere, something like that. So I guess my point is, I'm not making my point. My point is, the draw on this light may interfere with some of the tests that this is able to do, which I really need a transistor radio in here actually doing it. So, we're in pretty good shape here. Let's turn this off. Turn this off. There, get rid of that. So we have a zero adjust. Zero adjust on the VTVM. Did I not? Oh, okay, so this is how I should have done it. The zero adjust. So we just put this right in the middle. Zero adjust it to 0. That's probably what was wrong all this time. Okay, so let's do an accurate voltage reading. Put this on the 15 volt scale. Set this 10 volts, plus or minus a volt. Okay, so what happened to the other test lead? Where did you go? Here it is. Negative to negative. 10 volts. So we're on the 15 volt scale. It's still reading way low. It's reading way low. And we'll dial this way back and we'll flip this to 1.5. Sure looks like it sticks there, but it's a little sticky. It's definitely a little bit sticky in here. Not terrible though. So this is now reading roughly 1 volt, but in fact it looks like I'm putting in about 2.5 volts. Very good. Yeah, that's good for today. Gotta think now what more I can do or should do with this before actually trying it out on a radio. And I'll need a radio. That'll be a while from now before I get around to that, because I've just received a another old tube radio from someone to fix up. That's what'll be in my shop next. So that may be it for this for now. I'll carry on with it when I get around to messing around with the transistor radio. In the meantime, I'll be back to tube radio repairs starting tomorrow. Fantastic little machine. Switch it off. Beautiful. There you can see where the pointer floated up to. Probably this should be zeroed now. Okay, that's good. Got it. Fantastic. Oh, I got to put a pointer on there. See ya. See you on the next video.